Welcome to Chemistry with Crip. This video will review the common chemical systems that have been classified as either endothermic or exothermic processes. Whenever a process results in an increase in potential energy, attractions in that system will become weaker. This gain in potential energy of our system must always come at a loss of the kinetic energy in the surroundings. Since the energy comes into the system, it is an endothermic process, and the change in heat energy for our system is positive. In the example shown of either solid transitioning to liquid, called melting, or of either liquid transitioning to gas, vaporizing. Both are considered endothermic processes. Attractions are being overcome and weakened. The potential energy of the system increases because it is absorbing kinetic energy from the surroundings. And delta H, the change in heat energy for the process, is positive. This applies to whenever bonds are being broken. In the former example, the bonds were between molecules. Here in this example, the bonds are inside of molecules. But the principle is exactly the same. Bond breaking is always an endothermic process that weakens attractions, increases potential energy at the expense of the surroundings, and having a positive value for delta H. Furthermore, whenever a process results in a decrease of potential energy, attractions in that system will become stronger. This loss of potential energy in our system must increase the kinetic energy of the surroundings. Since the energy goes out of the system, it is an exothermic process, and the change in heat energy for our system, delta H, is negative. In the example shown of either gas transitioning to liquid, condensing, or of liquid transitioning to solid, freezing, both are considered exothermic processes. Attractions are being formed and strengthened. The potential energy of the system decreases because it is releasing kinetic energy to the surroundings. And delta H is negative. Again, this applies to whenever bonds are being formed. In the former example, again, the bonds were between the molecules. And here, again, the bonds are inside of molecules. But the principle is exactly the same. Bond forming is always an exothermic process that strengthens attractions, decreases potential energy, and increases that of the surroundings, having a negative value for our delta H, or change in heat energy. Till next time we consider the mysteries of the absolute, Crip.